Hey guys, hi. So this is my demo for the project which I made for Pixie. So my problem statement was to build a multimodal conversational AI that can turn wikihow-style recipes for making classic French cuisine using Google's Gemini API. I have used an Open AI chat GPT like GPT-4, but yeah. So now let's talk about how WikiHow style recipes look like. What do they mean, right? So WikiHow style recipes are pretty straightforward. What they are is basically, let's say you have a particular step, then an associated image. Like let's say stack and cut tortillas, and then you can have this fry in small batches, then you can have this image. So yeah, that's pretty much it about the problem statement. So there are four major components to the problem statement. First is data acquisition, indexing. Second is indexing. Third is building the AI itself, integrating LLM into it. And fourth, obviously, is documenting. So for the first part, I have, as mentioned, I've used YTDLP, right? I've used YTDLP to download the videos from the playlist which is given. And I've also downloaded all the thumbnails associated with it. I have not embedded those thumbnails into the videos themselves because we are actually not indexing on video, so it is pointless. Also, it saves compute costs. Uh, Other than that, so let's talk about transcribing. So after downloading all the videos and the thumbnails, I need to actually transcribe them. What transcribing basically means is to converting audio into text. And for that, I've used Deepgram's Nova 2 model, which is efficient and scalable. I could have used the Whisper 2 model as well, but the accuracy was good enough to for me to just continue with this model. One main thing in the Deepgram modeling is that there are certain parameters which Deepgram offers. One thing is smart format, which basically punctuates all the transcripts which you get. Another thing is summarize, which gives you a summary uh, from their end, like how your entire transcript feels like, looks like. Another important thing is the sentiment part. So sentiment actually has sentences after every logical pause. So that can actually help us to chunk better and extract those sentences instead of just uh, chunking, let's say, any random sentence together. So what we can do is we can just understand that, okay, after this point there's a logical pause, I will chunk these sentences together. So yeah, now let's talk about the data chunking part. In the data chunking part, it's actually pretty straightforward. Uh, what I've done is the sentences which I extracted from the sentiment part, I actually ended up using them uh, here as chunks, and I clubbed those two consecutive sentences as a single chunk because the sentences were pretty small. After that, there is a screenshot part as well. So after every chunk, after I've stored every chunk has an associated start time and end time. And that start time and end time is what helps me to extract a screenshot. So for every chunk, the start time of every chunk, I am extracting a screenshot for that particular part. So that way, my both screenshots and chunks are ready. So obviously there are additional remarks, but that can be discussed after the demo. And there's a bunch of different, let's say, data handling and data restructuring happening on here. Now let's get to the main part, the fun part. So even before I move forward, I actually had to define a lot of util functions here. So under configuration and helper functions, I've defined all my util functions, and I've also defined my OpenAI key. And just to authenticate it, is this like usable here. And as you can see, the API key is valid. After that, what I'm basically doing is I'm creating a new local vector store. And why I'm using a vector store is to store the vector indices. The store I'm using is quadrant. And I'm using quadrant because it has a way to actually store text collection and image collection separately. And because it's a multimodal model, I will be required to have both of these separate collections. And as you can see here, I then actually create the multimodal vector store index using LLamaIndex, and so that I can just always reference to it instead of me again calculating the indices again and again. So now let's talk about the retrieval part, because if after indexing retrieval comes in any RAG. So in the retrieval part, there are three separate kinds of retrievers which I've defined. One is a text and image retriever using text query. Another one is text retriever using text query. Another one is hybrid image and metadata retriever using image query. Right? The names are what they actually do. Right? So let's say if you have a text query and you need to get a associated text and image for it, you will get it. Same if you have an image query, basically if you have any image, and you want to check what is the file name associated with the actual image which is stored, right? Or with the top hit. So that can be fetched through this, and then I can use that particular metadata to again plug into the text retriever, and then I can get more information about the recipe itself. So let me just show you how this works. So let's say I provided in the text to text retriever how to make guacamole, for example, and it returns me the three top results on decreasing order of similarity. And as you can see for guacamole, it can easily tell that okay, this is the guacamole part, the timestamps, and everything is there. Same for the random image. The random image is of, let's say, chocolate crispy flake. And as you see, I just provided this path, right? And this image did not have anything else, any metadata associated with it. And then I fetched this part. And now I actually have the metadata associated with this image, right? And then I can just use basically chocolate crispy flakes. And then I can pass it to a text retriever to just get the recipe for it. And now comes the hybrid part, which will help me to, let's say, fetch both. If I have text and I just want both, then I can just use the text and image retrieval, and that can help me provide, let's say, two results for text, two results for image. And as you can see here, let me run this only. Okay, yeah. So the separate nodes which are there, as you can see, there are two nodes which are there for text, node 1, node 2. And it is about black beans, and as you can see, both the nodes are about black beans themselves. Yeah, see black bean soup here in node 1, black bean soup here in node 2, and so are the corresponding images as well. Fine. So after that, let's move to the LLM part or the AI part. So the model, which as I mentioned, I'm using is Open AI GPT-4, and I'm using GPT-4 version preview. And the max tokens which I am actually going for is 2500, and temperature is 0.8. I am going for a temperature less than 1 because the prompt statement mentions for us to not be creative and just stick to the recipe which is actually mentioned by the chef himself. So now let's talk about the final response using both text and image prompts to the LLM model. So there are two main things. So first thing is the text and image processing for LLM screenshots. So the problem statement actually defines two ways. So either I fetch all the necessary screenshots for the wikihow-style recipe, right? And after every step, I post that particular screenshot. Or what I basically do is, after every step, I ask Dall-e to generate an image for me using the necessary context, and then I can use it. So I have implemented both here, right? And as you can see, there's the image processing LLM screenshots one, and image processing LLM Dall-e one. And yeah, I just called the screenshot flow here just for you guys. So as you guys can see, I simply asked it one thing, how to make guacamole step by step. And it just passes the model index. And I just also mentioned some other metadata, which all steps are related to guacamole. So as you can see, I can easily get the node here, right? And then I get this particular image here. Same here. I can again get an associate screenshot. So obtain ripe avocados and cut them into halves, and I get this. Same for, let's say, remove the pit by cutting or giving it a bag. I can get other things, right? But yeah, as you can see, I think there was one image of a chicken in the middle. So that ideally should not happen, and that is why I decided to go with the Dall-e part as corrects it. So to better correct it, what we can actually do is we can make a custom retriever which has more context from a retriever standpoint, not from an LLM standpoint. And then I can actually use a response synthesizer to actually make a better response. Okay, now let's talk about the app, right? Okay, so that was the screenshot one. The Dall-e one will actually come in later, and I'll explain how that part works. So I will also just tell about one image to text retrieval part, right? So in now I discussed about, let's say, image to image retrieval or text to image retrieval or text to text retrieval. For image to text retrieval, what I am basically doing is that I am getting the metadata from the image as I mentioned, and then I am basically using that text to do both text and image processing. And now there's an alternative to not use a separate retriever and LLM model. That alternative can actually help you to just use a query engine. And that query engine, like simple multimodal query engine, has actually both the retriever and the uh, model itself, the LLM itself. So for the Jupyter Dash application, what so okay, that was the main part of the code. Now let's talk about the UI layer, right? I made a Dash application with only one callback function here, which is handling everything, and this is how it looks like. A cookbook AI, all this with account, and I can just enter my text, I can drop images, and I can submit certain things there. So, because Dall-e will take a lot of time for me to generate all the images, so I will, let's say, show you a prompt which is done from beforehand, and one prompt I can show you on the demo itself. So, let's say this is the prompt which I earlier entered. I just provided them with this particular image. Let's say, yeah, let me show you the image which I'm talking about. And then what I can do is that I can just get this cookbook part. As soon as I submit, what it can basically tell me is that okay, these are the particular steps and these are the Dall-e generated images, right? Feel for the visual and cut on each side of it with a sharp knife. As you can see, that is happening. And same, ensure there is enough skin on the chicken. Can be used to help trust the bird. And then you're tucking the wings part and which are going to trust the chicken. So all of those images are generated end to end, as you can see. Even for let's say the even if the transcript actually does not have anything, so it will just tell me okay that okay. The transcript does not provide further details here, but typically it can be preheated in an oven like this and on the particular temperature. But again, most of the transcript is related to Jaques himself. So fine. This is one of the ways. Then other than that, I think one of the other ways is very straightforward. So if I select how to make guacamole, submit this. Okay, so it is bound to take some time, but let me show you what happens. So the first thing is my RAG is, as you can see, it is active. It extracted the nodes which are necessary. And then obviously it'll be using Dall-e, which will take some time. And in that time, what I can do is I can explain you how my main part works, right? So let's say if I've clicked on my submit button, what actually ends up happening is, so I check whether if it is just a text value and there is no image. So I end up calling my text and image processing LLM Dall-e, right? And inside that, so let's say this text and image processing LLM Dall-e. So let me just find that message for you. Yeah, here it is. So here what we actually do is that we see if there is no image metadata, I just directly just call the text retriever and I get all of the necessary text. I create a QA template along with it, and then I basically call this complete method, which is provided by the multimodal index, which is there. And yeah, as you can see, I have provided the necessary context string and the query string, and this together forms the template string or the prompt basically, and this can be then passed to the LLM. After it being passed to the LLM, what I basically do is I then see what are the individual steps in the final response provided by the LLM, and all of those particular steps, what we basically do is that we end up providing Dall-e 3 generated images for each of those steps. So yeah, I think that is one of the ways to go. And fine. So let's see if, as you can see, okay, our images are getting generated, but let me see if it is still generated. Let's take a look at the screenshot flow which I was talking about. So the screenshot flow is actually really good. So if you can see for firstly I've got a fork, bowl, and dice 3/4 of a tomato and added to the avocado. So it's pretty great, but sometimes it is really inaccurate. Why? Because of the context, right? So let's say if I send just this part to the RAG, what will happen is your RAG will not have enough context, and your LLMs are bound to have a lot of context. But how Llama index actually defines your retrievers is the retrieval nodes actually do not have a huge context there. So, and that is why it is actually necessary to make a custom retriever in this case. And same why I'll suggest a custom response synthesizer as well, because it is bound to be formatted in a way which is much more defined than me, let's say, passing over every RAG image and combining it with the text. Oh, great. Yeah. So now I think after how to make guacamole, it has actually provided with me the steps and the required images as well. So as you can see, the first one, which will be select small ripe avocados, cut them into half, and remove the pit. It shows exactly that. Same here for scoop out the avocado flesh, cut it into pieces, and rinse, cold water. That is also there. Same place avocados in the bowl, over mashing. That is also there. Same adding seasoning, mix all the ingredients. So as you can see, so text part also works. Image and text part also works, right? And now I will just show you the flow for only image. Just provide it only the image, and then let's see what happens. So I can provide them something new, something which is not have been metadata in the file name, and this looks good. Okay, I have done this. So submit. Now it will take its own sweet time. As you can see, the RAG has started to work, and it is able to identify the image directly, which is great actually. But this is not your image which you provided. This is the image from your retrieval index. As you can see, it is able to generate an image of the new clam chowder which was mentioned. Uh, and yeah, then it basically tells okay. The image, it also tells you the text about the particular image as well. So yeah, I think this test case is also fine. Now let's take a look at the last test case, which is basically providing it with a text about a dish which it does not know anything of. So let's clear the output here, and let's clear input here. Now let me just write how to make on tortillas. Yeah, as you can see here, even for the corn tortillas, the provided transfer does not have any specific recipe for corn tortillas, which is true. It, and it also tells you that it does mention a large tortilla and the base, that it is the base for making quesadilla, because that was the transfer which was provided. And let's say if I prompt it further, and if I change the final template, I can actually ask it to generate further steps for it using a similar kind of approach as uh, Jaques. So yeah, that is the end of my demo. I think there are a lot of separate questions as well, which we need to clarify. And there are a lot of performance increases as well, which we can use. And yeah, I think see you guys whenever we discuss this thing. Thank you.